Afternoon, everyone. Kevin with Halo Power here with my partner Connor, and we're out at South Cooking Lake where something tragic has happened. Homeowner was putting in new fence posts, and he did have the utilities marked. And when he was augering down for his post with the post hole digger, he did hit the underground USEB cable and damaged the power line to the house. So we're here today. We're going to do an underground splice and get this cable fixed up. So you can see down in the trench here, luckily they didn't shear the cable right in half with the post hole auger, but it did damage it enough that it created some sparking. They were able to wrap some tape around it and kind of seal it up, so it's been good for the last day or so. And you can see it's fed from the Fortis meter right here on the power pole. Now the good thing about this is this meter socket has a main 100 amp breaker on it, so we do not actually have to have the utility company out to pull the meter. Okay, well, we're off to a good start. The screw that holds the bottom cover on down here on the bottom is actually it's stripped, so we'll have to get that open so we can actually get into the bottom of this meter socket. It's always something. Okay, well, luckily Connor had a pair of vice grips, so we're gently getting this thing out. She's squealing. Okay, we got the screw up, thank goodness. So I'm going to pull this thing open. And that's exactly what I expected to see. So very typical Fortis meter socket. All the power's coming in on the shiny parts down there, and these are customer connections here. Okay, so I've shut down the main breaker there, but I just want to make 1000% sure that this is actually de-energized before we get rolling here. Okay, 0 volts, nothing between our hot and neutrals, nothing to ground. Okay, we're good. I can start taking this thing apart. So we're going to end up disconnecting this, pulling it out, and then we'll cut back that damaged part of the cable and run the new cable back in here and reconnect. Okay, so this shiny copper one, that is our concentric neutral. And then these are our 2 hots going to the house, leg 1, leg 2. A lot of guys will call these phases, but it actually isn't, because this is a single phase system. So you only have 1 phase, but you have 2 legs. And between the 2 legs, you got 240 volts. Beauty. Here's what I wanted to find. Okay, perfect. Okay, so this is what I wanted to check before we actually cut this cable, was the size. So you can, if you can read that there, it's a 1/0 aluminum, and then it's got a reduced neutral of number 4. This is exactly the same size cable I brought, but we don't want to go and cut this and then find out after the fact we didn't bring the right cable. So yeah, if you're doing one of these, step 1, make sure you have the right cable to match what you're cutting. All right, so we're going to unwrap this. I got a few pictures from the homeowner the other day, so I got a pretty good idea of what we're looking at here. Okay, so we got the tape off, and you can see it took a pretty big chunk out of one of the legs, damaged the concentric neutral quite badly, and even took a chunk out of the other leg. So there wasn't much left keeping this house on. They were able to keep it going here for the last 24 hours or so, but it's only a matter of time till it would have blew out completely. Okay, so we're going to cut this off where all the damage is and start over. Okay, so what I'm going to do is strip back the outer jacket on the length that's still running back to the house, and we'll start getting it prepped up for the splice. Okay, so to do this underground cable repair, we are using a 3M USEB splice kit. This is exactly what they're designed for, is making an underground repair. If you look on the back, it actually has some really good instructions, and I'll just go through it with you here as to how we got this end of the cable prepped. So the big thing with these is making sure that where we have our crimped splices on the cable, we want to stagger them, because you don't want to have two metal barrel crimps like these laying right on top of each other, because they're both going to be live when the power's on. So what it shows is from the outer jacket, which I've cut back, our longest conductor is 10 inches, our shorter conductor is 6 inches, and then we leave about 4 inches of the concentric neutral. So on this particular cable, because I had to cut it back and this is all we've got to work with, we've got this length here at 12, or sorry, at 10, this one at 6. This is going to be our 4-inch one, because on the other cable that we're going to add in, this section actually has to be 24 inches long, because you'll see when we put it back together, we're actually going to wrap it back around the entire splice, so we've recreated that concentric neutral. So this is the new cable going in, so what I'm going to do is I'm going to cut back the outer jacket at about 10 inches here. It's nice, it's about 20 degrees out today, so this cable is very easy to work with. Different story when it's 30 below. Okay, I'm going to show you the mistake I just made, because I just realized it. If you recall, on our instructions here, it says that this section of the concentric neutral needs to be 24 inches long. I've cut this back only to 10 because I was thinking about just the 2 legs, but I'm actually going to cut this outer jacket back 2 feet so we have enough of this copper concentric neutral to do this properly. So this is what you should have on the other end of the cable, is 2 feet of the jacket exposed, so, or cut off actually, so that we have 2 feet of this concentric neutral right there, because that's going to get wrapped around the entire splice when we put it back together. Next thing I'll do is I'll cut one conductor at 10, and then we'll just mate it up to make sure it's bang on for the other one being at 6 inches. Okay, so I've got these prepped up, and you can see if I just dry fit it up together, this is what we're after. When these get spliced together, it's basically going to be a nice straight connection like it was from the factory. Okay, so we're just about ready to actually crimp these together with our gator press. But I want to show you one thing that many a good electrician has forgotten to do before he splices them. These shrink tubes right here, they need to go on before you do your splice. Because once you've crimped them, you're hooked. Lastly, this here is the large overall heat shrink that we're going to put over the entire cable. Again, you don't want to forget to get this on the entire cable. Slide it over top. Now we got nothing to worry about when we go to barrel splices. Okay guys, so what we're going to be using for doing our compression splices is our Gator electric crimper, and this will ensure that it is a good crimp. Very expensive piece of equipment, but we can't be without it in the industry we're in. Once it gets the right pressure, it just releases. So, and these crimps are actually filled with a deox compound. So you can see when I put it on, that gray goop that's on there, that's a deox, especially made for aluminum connections. go. Okay, that one's good. There we go. Okay, so we got both legs spliced. So what we're going to do is shrink down these heat shrink tubes before we carry on with getting the concentric neutral done. When you're doing this, you gotta be so careful. You want to keep that torch moving all the time. That looks good. Okay, so if you have a look down here, you'll see we've got our two crimps done, nicely staggered, and the cable lays very nicely. So what I'm going to do is just give it an overall wrap of black electrical tape before we get this concentric on. So we've got the concentric all spliced together and just wrapped around here. So I'm just going to give one more overall wrap of tape here, and then we'll shrink down the overall sealing shrink, and this will be done. Okay, after a bit of a wrestling match there, we got the big overall shrink on. Now here's what's really important. When I'm doing this, I'm not going to concentrate a bunch of heat in the center. Biggest mistake you can do is overheat that center, melt the inside shrinks on your barrel crimps for the two hot legs, and then everything touches together, and when you energize it, all you get is a big boom. So we want to make sure that we get a seal on the end, and this will actually leach out a adhesive material as we shrink them down. But I'm not going to worry too much about the center here. I'm just worried about the last 4 or 5 inches here where I really want it to seal. Yeah, so if you have a look at here, you can see the end is sealed nicely. You can see this goop that's coming out. Hot stuff. But that's the torch. Come on, baby. That's the sealing. Oh my God. So you can see that adhesive is starting to leach out there. So that's going to really make sure this thing is weatherproof. All right, after some tedious torch heating, you can see we've got the splice complete. There's the adhesive out the bottom. That stuff is what really makes sure this is sealed and weather tight. You can see this side's already set up. It starts to harden again. So yeah, this is done, ready to be put back in the ground. So we're going to get the other end of the cable back up into the meter, reconnect, and fire up. Okay, so we've got our new cable pulled up into the customer connection side of our meter socket, and I just finished taping up our neutral, so I'll make my connections in here. You're good. Okay, so we've got our deox compound that we put on. Very important, this goes on for all our aluminum connections. We're all terminated in here, so we put the cover on, fire up. Well, nothing went boom. All right, well, we're all done. Power's back onto the house. Everything went real smooth with this splice. So there you go. If it just so happens you're digging in your backyard and something bad happens, and geez, I hope it doesn't, you know who to call.